Here are our objectives for section 1.5. So first of all, we have solving quadratics by factoring, solving quadratics by the square root property, solving quadratics by completing the square, solve quadratics using the quadratic formula, using the discriminant to determine the number and type of solutions, and determining the most efficient method to use when solving a quadratic equation. Okay? So, let's talk about factoring first. Okay? How many different ways are there to factor? A lot, right? There's a ton of different ways to factor. So I'll remind you of a couple of them. And then if you need to talk about some of the other ones, I'll be happy to help you with those. Okay? First of all, let's remember this property. If A times B equals 0, what has to be true about either A or B or both? Correct. Either A equals 0 or B equals 0. Or they could both be 0. Okay? So if you have just a simple trinomial like this, let me remind you how to factor that. Okay? If it's a simple trinomial where the leading coefficient is 1, we can say, well, it multiplies to be 10 and adds to be negative 7. So we could do that real quick, right? Okay, but let's think about this in the bigger picture so we don't have to do a whole bunch of examples, if that's okay. In Algebra 2, we did the AC method. And we multiplied A and C and got 10. And then we found B, which was negative 7. And not just looking at the last and adding to the middle, but looking at the AC, what multiplies to be AC and adds to be negative 7. Well, in this case, it's exactly what you guys just said, the negative 5 and negative 2. But now I don't have to do a whole bunch of examples when A is not 1, right? Because it's the same kind of process that you use, okay? So we know it's negative 5 and negative 2. So because the leading coefficient is 1, we can go straight to the factors. X minus 2, x minus 5. Okay? Now, if A was not 1, let me remind you what to do then. Okay? If we had x squared minus 7x plus 10, and we decided that it was negative 7 and negative 2, what we could do is rewrite the middle term to become these two terms. Negative 5x minus 2x plus 10. So we split that middle term into two parts. Do you remember doing that? So then there was 4 terms, and when there's 4 terms, we try to factor by grouping, if at all possible. Okay? So looking at the first 2 terms, what is common in just these 2 terms? X. What's left if I factor an x out of each term? X minus 5, right? Now just look at the last 2 terms. What's common in those 2 terms? So for sure 2, right? But you chose negative 2 because you know that our parentheses have to be the same. And if I just take out a 2, I would get negative x plus 5. I don't want that, right? I want exactly the same parentheses. So if we factor out a negative 2, we do end up with x minus 5. Now we look at this term and this term. What do they have in common? So that is a common factor. And if I factor out an x minus 5 from each term, what's left over? X minus 2. Now, you notice pretty quickly that we got the same answer as we did this way. This was just the shortcut because this has a leading coefficient of 1. So this was what we do if we don't have a leading coefficient of 1 or we just need the practice. Is that fair? Okay. So these are what is called the factors. These are the factors. Okay. If you wanted the solutions, what would you do with the factors? Okay, so you could, right? The shortcut would be to flip the signs. Can we always just flip the signs? If this said 2x or 2x minus 5, can I just flip the sign and say the answer 5? I couldn't, right? So if it's just x plus something or x minus something, yes, I can just flip the signs. Okay? But just as a practice, what we want to do is we want to take each factor and we want to set it equal to 0. So while these do work out, x does equal the opposite of what's there. It's a minus 2 there. We know that the solution is 2. Same thing here. If I add 5 to both sides, I get x equals 5. realize that if this was 2x minus 5, I couldn't just say the answer was 5 because I'd actually be solving for x and I'd end up with 5 over 2. Okay? But because of this property that we talked about at the beginning, if I have two things multiplying together and I'm saying, okay, now solve this as if it was an equation, I know these two things multiplied together equals 0. I set both of these equal to 0 to see all the possibilities for x. Okay? Does that make sense? Okay, so factoring. Another thing that you might notice when we're factoring is you might see something that looks like this. X squared minus 25. So that's not a trinomial because there's only two terms, so it is a binomial. And hopefully you recognize right off the bat that there's something special about both of these terms. They're both squared. And what's happening between the two of them? We're subtracting. So this is called the difference of squares.
Miss Kingston?
Yes, ma'am?
Do you have Zach Hoffman?
I do.
Can you send him to the office, please?
Can he come after we're done with the lesson, please?
Yes, ma'am.
Thank you. Is that okay? Okay. So when we're factoring the difference of squares, we say x plus 5, x minus 5. Where do the x's come from? The square root of x squared. Where do the 5's come from? Square root of 25, right? So it's just x plus 5, x minus 5. One's positive, one's negative. Okay? What if it was 4y squared minus 49? I'd still get two binomials, right? What would be in the binomials? Perfect. 2y minus 7 and 2y plus 7. Okay, I'm going to try to trick you. So I'm going to write it even in a different color. Are you ready? Now, I did warn you ahead of time I'm trying to trick you, right? Did I trick you? It's not a difference of squares, is it? Okay, this is the sum of squares. And if you ever come across a problem that says factor, you're done. This is prime. Okay, you can't factor the sum of squares. Now, there may be times where you can factor out a common term, right? If I would have put 36 here instead, I could factor out they're both divisible by at least 2, probably more, right? All you could do is factor out a common term. You couldn't factor this to make it look something like this. Okay? So what about this one? So this one is the difference of squares. Really just these two examples right here, right? Okay? What about this one? Difference of cubes, right? Do you remember how to factor the difference of cubes? Okay. So what kind of, what do my factors look like? Do you remember that? Is it just two binomials again? Not this time, right? I have a binomial and a trinomial. Okay. Now, how do I get the terms in the binomial? That's just the cube roots. Okay, A and B. How do I get the trinomial? Do you remember that? It's just a pattern. So can I remind you of the pattern? Square the first. Square the last. And then